Hello student, I am back again with chemistry video. As your board exam is approaching, I have prepared this video including very useful tips for important questions for exam. To watch videos, like, subscribe and leave a comment below. Today topics is about Aldol condensation and Perkin condensation. Very important reaction of aldehyde and ketones. These are the chemical properties of the aldehyde and ketones. Aldol condensation. What means aldol? Aldol means ALD. ALD means aldehyde and OL means alcohols. Aldehyde with alcohols. Aldehyde with alcohols. And ketone also gives aldol condensation. So we can say aldehyde with alcohol and ketone with alcohols. So we have to remember that both aldehyde and ketone having alpha hydrogen gives aldol condensation. Both aldehyde and ketone which contain alpha hydrogen, they give aldol condensation. Presence of dilute NaOH in the aldol condensation. So molecular formula of aldehyde is C-double-bond-OH, R C-double-bond-OH. R is a alkyl group, and this is the functional group of aldehyde. In aldehyde, C double bond carbonyl carbon bonded with hydrogen, but in ketone carbonyl carbon bonded with both, in both sides there will be carbon, and this alkyl group, this both in both sides there is a alkyl group. This both alkyl group may be same or different. If there is a CH3, C double bond O CH3, it means here is a methyl group and here is also methyl groups. This may be different, or it may be presents like this C2H5. There is a methyl group and here is a ethyl group. Here C double bond O, this is the carbonyl group, this is the carbonyl group, and this is the functional group. This is the functional group, and functional group bonded carbon. Functional group bonded carbon is alpha carbon. This is alpha carbon, and alpha carbon bonded with alpha carbon is a beta and gamma and delta, so on. So alpha carbon containing hydrogen is called alpha hydrogen. So this is the alpha hydrogen. Here is a 2 alpha hydrogen, and this is the beta hydrogen, this is the gamma hydrogen, this is the delta hydrogen. Alpha carbon containing hydrogen is called alpha hydrogen, and alpha carbon is the those carbon which bonded with functional group. And here this alpha hydrogen is acidic, but other hydrogens are non-acidic, because we know that aldehyde or ketone, this carbonyl group, aldehyde or ketone containing carbonyl group are electron withdrawing group, so they show minus I effect. Carbonyl group show minus I effect, electron withdrawing group. So electron withdrawing group increase the acidic strength, it attract electron towards itself, and acidic strength will increase. So here alpha carbon is directly bonded with the carbonyl group, and beta, gamma and delta are far from this electron withdrawing group. So minus I effect decrease with the distance. Minus I effect decrease with distance. So this hydrogen is more acidic, but this hydrogen are not acidic. Identify which aldehyde or ketones contain alpha hydrogen and which aldehyde ketone does not contain alpha hydrogen. In methanol, the C double bond O, this C double bond is the carbonyl group and this is the functional group. Functional group bonded carbon, there is no any carbon, so there is no presence of alpha carbon, so there is absence of alpha hydrogen, and it does not give aldol condensation, it gives Carney-Zaro reaction. CH3C double bond OH, here carbonyl group, this functional group, bonded carbon is a alpha carbon, and here is 3 hydrogen with this alpha carbon, so 3 alpha hydrogen, so it contains alpha hydrogen, it gives aldol condensation. Next example, CH3CH2 C double bond OH, propanol, and here is functional group bonded carbon, this is the alpha carbon and this is the beta carbon. This alpha carbon contains 2 hydrogen, so there is a alpha hydrogen, it gives aldol condensation. And this is the benzaldehyde. In benzaldehyde there is no presence of alpha hydrogen. In benzaldehyde C double bond O, this is the functional group, and here is a carbon, and here is no any alpha hydrogen, there is no hydrogen, so it does not give aldol condensation. So if there is a absence of alpha hydrogen in aldehyde, then they gives Carney-Zaro reaction. Absence of alpha hydrogen gives Carney-Zaro reaction. Some example of ketone, here acetone, propanol, CH3 C double bond O CH3. The carbonyl carbon, bonded carbon is a alpha carbon, this is also alpha carbon. It contains 3 hydrogen, that is a alpha hydrogen, here is also 3 hydrogen, that is a alpha hydrogen, so it gives aldol condensation. Next example, carbonyl group C double bond O, this is the functional group, bonded carbon, here is contain of 3 hydrogen, this is alpha carbon, this is alpha carbon, and this is the beta carbon. Alpha bonded carbon is a beta, so here is a presence of alpha hydrogen, so it gives aldol condensation. Next example, acetophenone. In acetophenone C double bond, this is the functional group bonded carbon is a alpha carbon, here is also alpha carbon, but there is no any hydrogen, but here is 3 hydrogen, so it gives aldol condensation. How can we define aldol condensation? 2 molecules of an aldehyde or a ketone, 2 molecules, there should be a 2 molecules of aldehyde or ketone condense in presence of dilute alkali. Dilute alkali may be NaOH, Na2CO3, BaOH2 to form beta hydroxy aldehyde. Beta hydroxy, hydroxy means OH, hydroxy. In beta position we know the alpha, beta, gamma position. Beta hydroxy aldehyde or beta hydroxy ketone respectively. This reaction is called aldol condensation. Aldol condensation normally of 2 types, that is a self aldol condensation and cross aldol condensation. Self aldol condensation means 2 same aldehyde, both aldehyde should be same. For example, CH3 C double bond O H, this is the acetaldehyde, and we should use CH3 C double bond O H. This is also acetaldehyde. Both aldehydes should be same, or both ketones should be same for self aldol condensation. And in cross aldol, cross means 2 different. 2 different means 2 different aldehyde, 2 different ketones, one aldehyde and another ketones, gives cross aldol condensation. From both self aldol and cross aldol condensation, the product form is beta hydroxy aldehyde or ketone. Let us see some examples of aldol condensation starting from self aldol condensation. In self aldol condensation, both aldehydes should be same and should contain alpha hydrogen. Here acetaldehyde, or you can say that ethanol, Al aldehyde, ethanol. This alpha hydrogen is bonded to this oxygen, and OH will be formed here, and this C double bond OH, we have to write C double bond OH, this functional group, write in right hand side. After that, write that carbon which lose alpha hydrogen, this carbon CH2, and this carbon should be bonded with this carbon where hydrogen bonded with oxygen OH. OH carbon should bonded with this carbon, so CH, this carbon bonded with this CH2. So beta hydroxy aldehyde is formed here. This is the functional group, and this carbon is alpha carbon, and this carbon is a beta carbon. In beta position there is a hydroxy group, so we can say that beta hydroxy aldehyde. And IUPAC name, 1 aldehyde has a priority higher than alcohol, so 1 2 3 4, 3 hydroxy 1 2 3 4, but single bond carbon contains single bond AN, and aldehyde 3 hydroxy butanol. This is the self aldol condensation for aldehyde. For aldol condensation, how can we remember the aldol condensation? What product will be formed? Let us see by this trick. First of all, write that molecular formula of aldehyde, CH3 C double bond OH, and another CH3 C double bond OH, presence of dilute NaOH alkali. So here is a 3 alpha hydrogen, we take 1 alpha hydrogen here, and here is a 2 alpha hydrogen. This alpha hydrogen bonded with this oxygen. Now this alpha hydrogen bonded with this oxygen. So how to write the product? First of all, write that molecules which lose hydrogen, that is alpha hydrogen, in right hand side C double bond OH, and do not write this alpha hydrogen, only write remaining part CH2. After that, here is a bond, we can put here bond, and this bond should bonded with this carbon which contain oxygen, so this carbon which contain oxygen, double bond O, but we can't write double bond O because hydrogen is already bonded with this oxygen OH, and write down the remaining part with for this carbon. Here is one CH3 group, and here is one hydrogen group. So this is the beta hydroxy aldehyde. For ketone, self aldol condensation, we use acetone. Here is also acetone, showing 1 alpha hydrogen here in acetone. This alpha hydrogen bonded with what? This oxygen, and form OH. After that, this carbon should be bonded with this carbon. This carbon contains CH2 minus, and this is C plus. So this CH2 bonded with this carbon. So we can write from last C double bond O CH3, this part. After that, that carbon CH2 which lose hydrogen, alpha hydrogen CH2, and this carbon is this carbon bonded with that carbon which contain OH group, so COH, and this CH3 is writing downward CH3. So what is the name of this compounds? This is the beta hydroxy ketone. This is the functional group, and this is the alpha carbon, and this is a beta carbon. So in beta position there is a hydroxy group, so beta hydroxy ketone. IUPAC name, start from this side, 1 2 3 4 5. Here is OH and ketonic group, so we give the priority for a ketonic group. So we count from this side, 1 2 3 4 5, and in 4 position there is a hydroxy, and 4 position there is a CH3. This is the substituent. So first of all we have to write the hydroxy group due to the priority order of hydroxy group. So 4 hydroxy 4 methyl, 4 hydroxy 4 methyl, pentane, 1 2 3 4 5 pentane, 1 2 into there is a O-N, so pentane 2 O-N. This is the self aldol condensation for ketone. In cross aldol condensation we use two different aldehyde or ketones. Here we are taking one ethanol, this is what ethanol, and this is a methanol. This methanol does not contain alpha hydrogen, this ethanol contain alpha hydrogen, so we have to remove alpha hydrogen from this side. We are showing a structure, this hydrogen bonded with this carbon bonded oxygen, this hydrogen bonded to this oxygen and form OH, and this carbon should bonded with what, this carbon bonded with this carbon, this hydrogen bonded with this oxygen OH, and this carbon bonded with this carbon. First of all write C double bond OH in last, C double bond OH, and after that this CH2, and this carbon should bonded with this carbon C, and it contains OH HH. The name of this compound is beta hydroxy propanol, and IUPAC name is 1 2 3 hydroxy 1 2 3 propanol, 3 hydroxy propanol. Next, Perkin condensation. Perkin condensation is very important. Here aromatic aldehyde is used with acetic anhydride. Aromatic aldehyde react with acetic anhydride in presence of salt of acid. Salt of acid means here is acetic acid presence, so we can use salt of acetic acid is CH3 COO. Aromatic aldehyde, for example benzaldehyde CHO. Acetic anhydride means acetic acid CH3 COOH, acetic acid CH3 COOH. Removal of water from acetic acid forms anhydride, that is a acetic anhydride CH3 C double bond O, and here is oxygen, and here is C double bond O CH3. This is the acetic anhydride. Salt of acid means CH3 COONA. Condensation product will be formed, and after hydrolysis of this condensation product it gives cinnamic acid and acetic acid. Let us see the chemical reaction involved in the Perkin condensation. Here the chemical reaction, here benzaldehyde react with acetic anhydride. This is acetic anhydride. We are showing mechanism here. From benzaldehyde C double bond O, and in acetic anhydride here is H2 in this carbon CH3, so we are showing here H2O is removed from this side, H2O is double bonded with this carbon, and this is the condensation product. condensation product. When condensation product on hydrolysis, it gives cinnamic acid and acetic acid. Cinnamic acid and acetic acid. Hydrolysis means lysis of water. Lysis of water means H plus and OH minus is break here. So this H plus bonded with this oxygen, H plus CHCOOH, and there is broken off bond, and CH3CO, here is a OH, CH3COS is formed. CH3CO acetic acid, and this is the cinnamic acid.